Want a quick way to check if a PCAP might contain malicious activity? Well, we could do this by implementing a tool called Snort. And once you get familiar with this tool, you could then eventually put this onto your resume. Now, we'll go over how we can install Snort along with a quick demo on how we can read a PCAP and generate a basic signature. Let's get started. What is Snort? Snort is an open source intrusion detection system slash prevention system, or an IDS slash IPS. It keeps an eye on your network traffic, identifying any suspicious activity, and promptly alerting you of potential threats. What makes Snort great is its ability to analyze network traffic in real time, and it is free. There are paid rules though that you can purchase, but there are out of the box rules as well, and you can also create them yourself if you're up for it. You might ask, I've heard about Suricata. What is the difference between the two? Well, not much really, except I would use Suricata in a production environment if you're using Zeek. The reason being is because you can use a field called Community ID for correlation. But either way, Snort is great to have in your lab and is extremely easy to spin up. Let's begin by heading over to their site, and you'll want to create an account as well to download the free rules. Alright, to begin, I am on my Ubuntu 20.04 server here. We're going to start with doing an update. So I'll type in sudo apt-get update and sudo apt-get upgrade -y. We'll enter in our trusty password. Once everything has been finished upgrading, now there are a couple ways that we can install Snort and get it up and running. For Snort, you can download a Docker image and then boot it up using Docker. However, we're going to be downloading it via Ubuntu. In order to do that, we'll start with making a directory called Snort. Type in ls just to make sure that the directory is there. And now we need to install some prerequisites. Now, a lot of these commands, I'll have it in a text file and I'll leave a download link in the description so you can just download it and then copy the commands from there. Now that the essentials have been downloaded and installed, we'll need to install Hyperscan's requirements for pattern matching, because what's new compared to Snort 2 is that it utilized Hyperscan for fast pattern matching using regex, which is quite nice. And again, I'll have this all listed in a document in the description down below for you to download and copy and paste. Now, when you do copy and paste, you might get hit with this sudo make install as the last command. Do make sure you hit enter so it can actually run, and then move on to the next step. In total, we need to download 4 prerequisites for Hyperscan for it to actually work. So currently, this is the second one. I'm going to do number 3 next. I do have to give a shout out to Noah Dietrich because I am using or following their documentation on how to get started with Snort 3. I personally have never spun up Snort 3. I've been using Snort 2 for a while now, but Snort 3 is all new to me. If you are interested in Noah's documentation, I am going to leave a link down below for you to read, as there are a ton of instructions within the documentation. Now we can start installing Hyperscan. Alright, so this took a couple minutes to install Hyperscan, but that's okay. Now, there are a couple of more prerequisites that we have to install before we can get Snort 3 up and running. Okay, and finally, we can update the shared libraries using sudo ld config. And now we can go and download the latest version of Snort 3. So to check out the latest version of Snort 3, we go into their GitHub page, and under releases, this is where we'll click. And this is the version that we want. Version 3.1.74 as of recording. Now this might change depending on when you try this lab, but do keep note of the version number. Now, depending on your Snort version, you want to make sure the version number matches whatever Snort version 3 you're using. Again, in my case, as of recording, it is 3.1.74. Now, if yours, let's just say, was 0.80, that's what you would do. And you would also change it over here. So I used wget to go out and download that file. After it's downloaded, we can then extract it using tar. And again, all of these instructions will be provided. Just be mindful of modifying and making sure that the version number that you're using matches. After all that, Snort should now be installed under the user/local directory. We could verify if Snort runs correctly, and to do this, we can pass the Snort executable to -V. So for example, I'll type in user local bin snort -V. Hit enter. Awesome. We should see Snort here, and we can see the version as well. 3.1.74. Nice. Now let's test out Snort with the default configuration file as well. In order to do that, we can just type in snort-c and then point it to Snort's configuration file. It's located under user, local, etc, snort, and then snort.lua. When we take a look, it says at the end, Snort successfully validated the configuration with 0 warnings. Now, because we are setting up a IDS, we want to make sure that both generic and large receive offloads are turned off on our network cards, because this can affect our packet inspection as well as analysis. And to turn this off, we can type in IP space A just to make sure what our network adapter name is. So in our case, we have the loopback, which is the first one, and then we have the second one, ENS34. Yours might be different, but mine is this right here. I'll take a note of that. Now we want to type in the following command, sudo eth tool-k, and then you want to put in your network adapter name. So in my case, it was ENS34, and then pipe that into grep. Grep is essentially a find tool. You can think of it as that. And then you want to search for receive offload and hit enter. As you can see, both generic and large receive offload is currently on. We want to turn that off, and we can do that via a service. So the next time we reboot Snort, it will turn off automatically. To create that service, we'll type in sudo nano. Now you can use vi if you want to, but I can never escape vi, so I'll use nano lib systemd system eth tool.service and hit enter. Now here we'll paste in the following, and yes, you guessed it, it will be in the document provided in the description. Something to keep in mind, on the line with exec start, we need to make sure that our network adapter, so this line here, is changed to our network adapter name. So again, mine was ENS34. I'll remove network adapter, ENS34. And then I will just go ahead and close it out by holding Control X and Y to save it and hit enter. Now let's enable and start the service. We can do this by typing in sudo systemctl enable eth tool or eth tool. Now that's enabled, we'll now start the service. Sudo service eth tool start. If we were to rerun the command and check our receive offload, it should now be off. Now here is the fun part. We'll create a custom rule for Snort to detect ICMP traffic. And to do this, we will begin by creating a file called local rules. First and foremost, I will create a directory under the user local etc rules. Now we can create a file under local etc rules, and I'm going to call this local.rules. Now this is a plain file that we can start creating rules for our Snort to look into or to utilize. I'll start typing in the alert itself, and then I'll explain what it does. All right, so this is a very basic alert, but essentially in the beginning, it's telling Snort to alert whenever they detect any of this traffic. And this traffic is specific to ICMP. Now, if I wanted to say maybe TCP or UDP, then that is where I would list it. Next is any. So that is your source address and then your source port. Next is the direction. So this is going to any. This will be your destination and your destination port. The next is your message. So if Snort detects this traffic, what kind of message do you want Snort to output? In this case, I said output ICMP detected if it detects any ICMP traffic. The next is signature ID. Now you might have noticed that it is 1,000,001. You might ask, why couldn't I just do 1? Well, that is because the numbers 0 to 999,999 are all reserved by Snort itself. So any custom rules, you want to start at 1,000,001 and increment each custom signature. So if I were to create another signature, I would put the signature ID as 1,000,002. Now, if you do want to learn more about rule creation for Snort, I'll leave a link down below for you to check it out. Let's test our new rule by running Snort and making sure that our rules do not generate any errors. So to do that, we'll type in snort-c and point it to our configuration file, and then -R and then point that to our rules file, just like that, and then hit enter. And again, Snort successfully validated the configuration with 0 warnings. Now let's run Snort and listen in on the traffic. While we do that, I'll hop over to my demo machine and ping another host just to see if our rule actually works. To start up Snort, we'll type in sudo snort-c, again, point it over to the Snort configuration file, then -R, point it to the rules, and then we need to specify our network interface. So in order to do that, we type in -i, and then type in your network adapter name. Again, my case was ENS34. And we want Snort to print out the alerts in a quick one-line format. In order to do that, we specify with a -A and type in alert_fast. Now I'll hit enter. And now Snort is listening in on that traffic using the network adapter ENS34. Now you can't see it, but I am on my other computer and I am going to run a ping. And just like that, perfect. Our rule actually works. I'm going to modify our Snort configuration so the next time we do not have to specify the rule's location. And to do that, we'll type in sudo nano, and then we'll point it over to Snort's default configuration. This configuration file is the heart of Snort, essentially. Here you get to list out your home net to your actual home network. Now, at the very bottom, we want to look for a field called IPS. And we can either scroll all the way down, or we can hold Control and W and then search for IPS. And here we go. A lot of these options here that are green, they are commented out. And we want to enable them. And we'll start off with enabling built-in rules. And if you read here, use include for rules files. So that just means that if you want Snort to run without specifying exactly where your rules are located, you can hard code it into this configuration file. So the next time Snort looks at this configuration file, it can be like, oh, there's the rules. I know exactly where to go to take a look. And that is essentially what I'm doing here. So in order to do that, we type in include, then equals, and then put it inside quotes, user, local, etc, rules, local.rules. Now do make sure after the quotation mark, you want to put a comma. Otherwise, when you run Snort, it'll likely give you an error. So let's go ahead and save this out. And we'll do this again, but I'll remove the rule path and just have it as Snort. Take a look at this default config, listen in using the network adapter ENS34, and use alert_fast. Heading back over to my demo machine, I'll ping it, and we do see some broadcast destination addresses. And there it is, ICMP detected. Perfect, so this is working. I'll go ahead and cancel this out. Now, I want to start expanding our rule set by downloading free rules, and to do that, we will install what is called pulled pork, which will, it's a funny name, but which will automatically grab the rules for you. Now make sure you're on the Snort directory that is listed under your home directory. And then I'll go ahead and copy and paste this command. And now we want to verify that pulled pork is running. To do that, we'll specify the location of where pulled pork is. So that is under your user local bin pulled pork 3, and then you want to specify pulled pork.py, so your Python file here, with a dash capital V. Awesome. So there's no errors, and we do see the version of pulled pork, version 3.0.0.5. Next, let's modify the configuration file. So we'll type in sudo nano user local etc pulled pork 3, and then there is a config file here. We are immediately presented with which rule set do you want to download, and they recommend to choose only one. We have the option between one of these three. I'm going to select registered, so I will change this to true. And then it says your Snort OINC code is required. Now, how do we get the OINC code? Well, if we go over to Snort's site, after you create an account and verify your account, you want to click on what is called the OINC code on your left-hand side. And then you have your API code essentially. So you want to copy that and head back to the terminal and paste your OINC code there. Optional, but if you wanted to download a block list, you can set this to true. But in my case, I'm just going to leave it as false. And because of that, I'm going to comment out this block list path because I don't need it. Now, if we head down, we want to uncomment snort_path. We want to make sure it is set to the right path. And then if we continue scrolling down, we see local rules. Again, we want to uncomment that and make sure that the rules or this directory is actually pointing to the rules that you have. So if I were to take a look, user local etc rules, local rules, that is correct. But I will remove this one here. Now, if you created a directory and placed your rules in a different directory from this, change it accordingly. And after that, we should be good. We'll exit out of this and save it. And now we run pulled pork 3. To do that, we'll point it over to where pulled pork is. Remember, it's in the bin, pulled pork, and then it's your Python file. Then you type in -c, lowercase, and then point it over to pulled pork's configuration file. And then hit enter. Okay, so I got an error. So rule_path is configured, but is not a directory. All right, if that's the case, we'll change our directory over to etc, type in ls, and that is correct. There's no directory there, so I'll type in sudo, and I'll make a directory called so_rules. And now let's try it again. All right, so I am getting a unable to load rules archive 422 client error, and we see that it's trying to get this file here 31740. If we head back over to Snort's website, let's scroll down here and take a look. Is there any, what was it, 31740? I see a 31470, but not a 740. Yeah, it doesn't seem like they have that file here. There might have been a typo. And if that's the case, I will likely just go for the latest version, which appears to be 31470. So the first one here. So I'll go ahead and copy this for the time being and put it in my notes because we might need to download this manually. Let's take a look at the Python file itself because there might be something there that it's telling pulled pork to look at a different version. And now this is the Python itself. So I'm going to just scroll down a little bit. Let's see what kind of configurations we got here. So we see the script name, tagline, okay, version string, rule set. So we can see the first rule set is community, and that's pretty much hard coded there. But then we see registered. Registered is the one that I want. And I do notice that there's a version at the end. Now I can change this and just hard code it, but before I do that, actually, let me exit out of there. I want to make a copy of the Python binary of pulled pork just in case I mess something up. And this is good practice, especially if you are planning to change a file. So I'll just call this old. Cool. Now let's go back and modify the original. So I'm going to remove the version and I'll hard code in the file here. So 31470 and then save that. And then we'll rerun pulled pork. And look at that. Perfect. So it seems to work. Now, I'm not entirely sure if that does work. Before we actually check it out, we need to modify Snort's config now to point to pulled pork's rules. So let's type in sudo nano, then go over to Snort's configuration file. And then we want to look for IPS again. So again, that is Control W and type in IPS. Now, instead of this local rules, we want to change it to pulled pork's rules. And it is located under the same directory where local rules is, at least in my case. So I'll type in pulled pork.rules and then I'll save that out. We could also cat it out just to take a look at what the rules is. And then I'll pipe it into less. Now at the top, rules file created by pulled pork. To use this file in your Snort Lua, you need to add the following settings, which we already did. And then you have chosen to enable SO rules or SO rules. To prevent errors when running Snort, make sure to include the following command line option, -- plugin - path, and then point it over to SO rules. Okay, I will exit out of this. And then we will run Snort and test it out. So we can type in snort -c and then point it over to our config and then specify our plugin path of SO rules. Then hit enter. And look at that. Cool. There are no warnings. So Snort successfully validated the configuration. That's awesome. Now for me personally, what I love to use an IDS for is to identify quick wins whenever I'm handed a PCAP. Because an IDS can generate a signature, and that signature should tell me what I should take a look at. Now, to demonstrate this, we're going to download a PCAP from Malware Traffic Analysis. And I'll make a directory under our home directory called test, and then I'll change into test. And now we'll use wget to download the PCAP. And then we will type in ls, then unzip the file. Okay, unzip is not found. That is no problem. We can go ahead and install unzip. Once that is installed, clear that out, and then I'll unzip that file. And the password is infected, all lowercase. Perfect. We got the file. Now let's run Snort and feed this PCAP to see what kind of signatures it generates. Type in Snort, again, point it to the config, specify your plugin path, and then we want to type in -r to read the PCAP, lowercase r, and then -A alert _fast. And then another argument I'm going to do is a -q. The reason for this is because I only want to see the signatures or the alerts that are generated. I don't care about anything else. And then we can hit enter. And okay, that is quite a bit of signatures. If we scroll up, yeah, that's quite a bit. So what I'm going to do is I am going to output it out to a file called pcap-signatures. Now we don't need that extension, but I'm just used to it. And now let's cat out pcap just to make sure it's all there. Perfect. We can have some fun with this now. We can start playing around with the cut command to make this data look more presentable. So in order to do that, we can do some command line magic by typing in cut-d, which is a delimiter, put it in quotes. I want to use the square bracket as a delimiter. And then I'll type in -f and type in 1. That's essentially saying I want to select field number 1 that is delimited with a square bracket. If I were to hit enter, that is what I would see. But I don't think field 1 does me any justice. So if I were to type in maybe 3, now I can see these signatures itself. But I don't like seeing the star and the other bracket, and also I don't like the quotation marks as well. So if that's the case, let me just keep cutting it. I'll eliminate the other square bracket, and then we'll type in -f1. Let's see what that looks like. Nice. So we still have the signatures, but the square bracket and the star is gone. Now, I don't like the quotation marks, so cut-d, let's wrap it in single quotes now. And then we'll type in -f1 just to see what it looks like. And we get nothing. Okay, what about 2? Excellent. So we have a bunch of signatures now. The next thing we can do is sort it and then unique, meaning deduplicate all of the alerts. Sort, and then I'll type in unique. Because I'm running out of space here, I am going to just clear that out. And then from here, I'll type in sort, pipe it again to unique -C because I want to count it. And then I can do a sort and hit enter. Isn't that cool? Let me sort it by using -NR. Now it's from the most signatures to the rarest signature at the bottom. And at the bottom, you might have noticed that there is a malware other, Win, Trojan, Whispergate. And just like that, immediately from that PCAP, I know where to look. Now I can just type in grep-I to forget about case sensitivity and look for malware under the PCAP signature. And that's it right there. So now I can take a look at this IP in that PCAP. If you could imagine, I have, let's just say, a 10 gig PCAP. Run it under this IDS and see if it generates any signatures. If it does, you can cut that 10 gig PCAP into a much smaller, manageable size. And then you can use your favorite analyzer like Wireshark and analyze that PCAP for you. Isn't that amazing? And that is how we get Snort 3 up and running. If you want me to create a video on how we can actually ingest these alerts into Splunk, let me know and I'll create that for you. That is it for the video. And if you enjoyed it, let me know by hitting that like button and subscribe if you want to. Remember to stay curious and do things differently.